Okay, this is an example of Doppler effect and Doppler effect basically tells us that if we have if there's an object that is moving towards us, then our frequency will increase, and if an object is moving away from us, the frequency will decrease. Now, the other way is true as well. If, let's say, the object is stationary and we are moving towards the object, that will again increase the frequency. And similarly, if we are moving away from the object, the frequency will decrease. So in this problem, we have a fire truck which is at rest. So for our case, the fire truck is at rest, it's not moving, but we are moving towards the fire truck. And in part B, the fire truck is rest again, but we're moving away from the truck. So if if we look at equation number 12.3a, it gives us the equation when the observer moving towards the stationary source. So we are the observer. Now that's basically frequency. The new frequency that we are experiencing will be velocity of the observer. Then we have the speed of sound wave, and then the frequency that the truck siren is at. Um, so yeah, so let's plug in all the numbers and see what we get. So for v observer, the velocity of the observer is 30 meters per second, and then the velocity of sound, the speed of sound is 343 meters per second, and then the frequency of the fire truck siren is 1650 hertz. And if we solve for it, we get 1790 hertz. Now, so we verified that, yeah, the frequency did increase. The frequency was initially 1650 and now it's become 790. So it did increase. So that means our observation or our calculation is correct. Now we have to look at what happens if it moves away. So for that, we need to use equation number 12.3b, and that is the only difference is that we have a negative sign here. So that's v observed by v observer by v sound, and then we have the frequency, and then again we plug in all the numbers here. That's gonna be 30 meters per second, and then we have the speed of sound, and the frequency is 1650 hertz. So that gives us 1510, which is, as we mentioned, lesser than the siren's frequency. So that decreased. So that means the formula that we used is correct. So one way to remember whether to take positive or negative sign is, we know that if the observer moves away, we need to have a frequency which is lesser than the initial frequency. So that's why we need to have a minus sign over there. And similarly, if we want the frequency to be higher than the initial frequency, we need to have a plus sign so that this term adds with 1 and then it increases the uh, initial frequency, and that's how we can verify that whether what we did was correct or not. Thank you.